Good day, my name is Madeline Esendino from the Group 5 of CPE 107L Section B2, and this is my Lab 2 vlog wherein I will answer questions number 1, 2, and 4 from the given Lab 2 questionnaires. I've excluded those questions that were assigned to me in a separate Word file for better view. Observing numbers 1 and 2, they are the same question except that I will just be using two different universal gates, which is the NAND and the NOR gate. So this is the expression that the question is talking about, and this is found in the video 15 SOP from the week 1. So I need to implement this in Logisim, but instead of doing it straight away, I would like to manipulate the expression first so that I can implement my circuit faster and easier. So how are we going to do that? We will do that by applying a couple of theorems or rules. So I wrote my solutions in this separate piece of paper, but I took a picture of this and placed it in another Word file so that I can explain how it works. So I've copied the expression, the O expression earlier. I just named it the F function here. And then I apply the double complement rule. The outputs of the double complement of an expression is the same as its original outputs. So if we complement an expression 2 times, they're basically the same. So we're not changing anything, we're just manipulating the expression. And then we combine that with De Morgan's theorems. One of De Morgan's theorems says that we can change the NOR to NAND. So how? By canceling one of these complements that we have just applied earlier and changing the OR operation into AND. So this is the final form of our expression. It is now a NAND expression. So let's go to Logisim and implement that circuit. I've already prepared a file for this number wherein 7400 IC or the NAND IC is already present, and this came from our week 1 archive. We created this last week. So going back to the main circuit, I will first place 3 inputs which represent the variables A, B, and C. And then I will just place some labels accordingly. So going back to the question, it is asking us to implement the circuit using only NAND gates and nothing else. So our present NAND gate here only have 2 inputs per gates. So medyo rarami yung IC na gagamitin natin, but that's okay. So let's go back to our expression. So we can see 4 different MINTERMS here, and each of them have at least one complement. So that means we need to create a complement of A, a complement of B, and also a complement of C, because we will be using it throughout the whole process. Okay, so 7400 IC, the blue dots represent the inputs, while the red dot represent the output. So how can I create a complement of A? By just doing this. Okay. Wait. Let's place some spaces here. Okay. Then finally, let's create a complement of C. Okay. So we can now move on to our first MINTERM. What is our first MINTERM? It is the complement of A and the complement of B and C inside a complement. So that's a NAND. NAND. So the complement of A the complement of B okay, what is the output of this connection? This is actually the complement of A and the complement of B and double complemented together. So to cancel that, we need to make it pass through another NAND gate before combining it with C. So this is the output. And then combining it with C, we get our first minterm. I'll be placing an output there. Okay, let's double check our minterm. Okay, so what I would like to do is pause for this part and check the output with a truth table generator site that I've found so that we can easily track mistakes if ever we've committed wrong connections. We can easily correct them before finishing the whole circuit and then working our whole way back. Okay, so the first expression is not A and not B and C. So we can see that the only instance where our output signal should be 0 is when C is turned on. So let's check that with Logisim by using the poke function and turning this on. So the signal is now turned off. But what if I don't want to waste my time in checking all of these combinations? So I can just go to project and analyze the circuit, and automatically Logisim will give me a table. So are they the same? Yes, they're the same. So now we can move on to our second minterm. So we will just repeat the whole process for the second and the third minterm. So at this point, maybe I will fast forward the video. Joke lang, sige wag na lang. I-explain ko na lang. The second minterm is A and the complement of B and the complement of C. So we need another IC for that. We have A and the complement of B and the complement of C. Cancel their double complements first. Combine them with the double complement, with the complement of C. So this is our second minterm. Let's place an output there. Okay. Let's check. Let's check it with the generator. Sorry. Complement of C dapat. Complement of C dapat. And then A lang. Submit that. So the only instance where our output should be 0 is when A is turned on. Let's check. It's turned off. Okay. Double checking with the truth table of Logisim. It's variable Y this time, and they're the same. Moving on to our third minterm. It is A and the complement of B and C. So let's place another. Pwede naman dito na lang. Meron pang gates. Yan. CB lang ang makakomplement. So that is A. Let's use this. Then the complement of B2 ba yun? Yes. And of course, don't forget to cancel their complement. Then adding another IC. Ito na lang natin padaan. Okay. And then combining it with C now. C lang. So it's here. C is over here. So this is our third minterm. Okay. Let's change the facing to east. Okay. Third minterm, CB lang makakomplement. Double checking with the truth table in logisim. The only instance where the signal is turned off is when A and C are turned on. For this table, it is variable Z and they're the same. Moving on to the fourth minterm, we have A and B and not C. Okay. So let's use this. Sayang naman. A and B. This is A and B. Then cancelling their complements. And the complement of C. The complement of C is over here. Ay, sorry. Na-connect ko sa output. Okay. This is our fourth minterm. Okay. C lang yung naka-complement. Then, checking if they're the same. This variable U here. The signal is 0 when A and B are turned on. So they're the same. So how are we going to combine these for minterm signals? So sabi dun sa expression, they are ANDed together. So we need another IC for that. Dito na lang. Kita ba? Yan. Yan, kita na. So, first I will combine them 2 by 2. Tama ba? Yeah. Let's use the spare gate here. So, combining one here. Another one. Okay, so we combine them. And then may complement sila sa taas. So, we need to cancel that complement here. Cancel the complement here. Okay. Next is these two naman. Commutative naman sila, so the order doesn't matter. I can combine the first IC and the third IC, the fourth IC and the second IC. Up to me. or up to you. So I need to cancel their complement because I combined them together. And finally, we get these two outputs, which is the end of our expression. Ito na. The moment of truth. If we committed a mistake. Okay. So this is our final output. We will double check the result of this circuit with the screenshot from week 1 expression. So if A and B and C are turned off, should be turned off. If C is turned on, then it should be turned on. It's turned on. C. Yay! Bumukas. Next. If B is turned on, or if B and C are turned on, the output signal should just be turned off. So if B is turned on, naka-off pa rin. B and C are turned on, naka-off pa rin. Next. If A is turned on, or if A and C are turned on, and if A and B are turned on, then the output signals should be 1. So let's check. A lang, naka-turn on. A and B, naka-turn on pa rin. A and C, naka-turn on pa rin. Finally, if all of them are turned on, then the signal should be turned off. Yun. So double checking with the truth table in Logisim. Are they the same? Yes, they're the same. So we've answered question 1. So for question 2, let's save this first. For question 2, we'll be doing the same thing except that we will just be using the NOR IC. So I've already prepared in another file for that, where the IC 7402 is present. This is the NOR IC. So it has 4 gates with 2 inputs each. But the expression, we will not be using this expression anymore because this is for the NAND question, right? So we have another conversion here. So basically, it's the same thing as number 1, applying the double complement rule, and then one of De Morgan's theorem. Ito yon yung NAND kanina. And then, complementing them again so that we can separate the terms inside of the MINTERMS. Kasi they're ANDed together eh. But, we're trying to make the expression a NOR expression. So, dapat yung MINTERM tsaka yung outer operations nila, lahat yun naka-OR. And then, their complement. Their complement per MINTERM. So, yan. So, ito yung final output. So, it's applying the double complement rule and then De Morgan's theorems 3 times. Sa labas, sa loob, tas sa labas ulit. Okay, so let's move on to our circuit implementation. The same process, I will be placing 3 inputs which represent the 3 variables. And then place some labels. And see. So, again, per MINTERM, we have a complement of A or a complement of C or a complement of B. So, let's create their complements first using the NOR gate. Ay, wait, masyado malapit. Yan na. Okay. Okay. As you can see, the output color from red it turned to green. That means it is now turned on, which is the complement of 0. So that's another way of cross-checking if the connection is working. Okay, now that we've created their complements, we can move on to our first minterm, which is A or B or not C. Not C. A or B. Syempre, naka-complement sila, di ba? So, pass through another NOR gate lang to cancel those. And then finally, combine it with not C. So, this is our first minterm. Ay, wait. Palitan natin yung facing ng south. Okay. This is our first minterm. Let's quickly double check that with our truth table generator. So, sabi ganito daw yung OR. Tama ba? A, tapos B, and not C. So, yan. Tama na siya. Submit. So, dapat daw, pag naka-turn on yung C, that's the only time where the output signal is 1. Check. Boom, hindi bumukas. Wait lang. Sorry. Sorry. A, B, and not C. A or B or not C. Check natin. Okay. So, we've spotted a mistake. Okay. Sabi daw, A. Ayun! Hindi natin sila na ano. Okay. Yun, buti na lang trace natin. So, before combining it with the not C, we forgot to complement A and A or B. So, yan. Para makancel yun, do this. Yan, before combining it with C. Diba maganda na chine-check every time? Okay. Okay, check ulit. Dapat naka-on to. Yan. Truth table. Ayun, they're the same. Moving on to the next minterm. We have not A or B or C. Ready natin to isa pa IC. Not A is over here. Not A or B. Ayan, complement natin sila agad. Saan na yung next dun? C ba? O C? C lang mismo. Ay, naka-turn on pala, sorry. C lang. Dito na lang siguro. Okay, so this is our second minterm. Bigyan natin ulit ng output. So, dapat naman naka-not si A. Ayun ay nabura. Yan. And lobat na ako. Saksak ko lang. Okay, so the only instance where our output should be 1 is when A is turned on. Okay, it's turned on. Double checking with the truth table. It's variable Y and they're the same. Moving on to the third minterm, we have not A or B or not C. So, CB lang ang hindi naka-complement. Ay, sorry. Not A nga eh. Then dito yan. Yan. Not A. Ay, mali daw yung connection. Kasi natin ipilit. Wala kasi silang connection. Joke lang. Ito. Not A. Na naka-OR with B. Where is B? Ito. Pwede natin kunin from here. Get their complement. And then combine it with the complement of C. Gawin ko lang tong pataas para malagyan natin. combined with the complement of C. Ay, sumobra. Complement of C is over here. Okay. Let's check the output. So, si B lang hindi naka-complement. Double check. Yan. The only instance where the signal should be turned on is when A and C are both turned on. Yan, nag-turn on siya. Double checking with the truth table. It's variable Z, it's the same. Moving on to the fourth minterm, we have not A or not C or C. Not A. Si B, ay si C lang ang hindi naka-complement. So, another IC. Yan. Dito na lang sa ilalim. So, natin to. Complement daw ni A combined with the complement ni B. Cancel their complement. And finally, combine that with AC. Ay. And this is our fourth minterm. Sana tama. So, si C lang ang hindi naka-complement. The only instance where the signal should be turned on is when A and B are both turned on. Yun, nag-turn on siya. Double checking with the truth table. Variable U, and they are the same. Okay. So finally, we will combine these. Sabi dun sa circuit natin. Ayun. Circuit expression natin. Ayan, ano lang sila. Nor sila individually. So that means after combining them 2 by 2, we need to combine them 2 times again in the NOR gate. Kasi wala silang complement sa taas. Di katulad ng NAND kanina. So, let's turn this off muna. Yan. Add another IC for this. Yeah, kasi alanganin. Yan. So, combining them 2 by 2 first. Yan. Yan. Of course, get the complement. Yan. Tapos ito. Yan. Ayun, kapos ng isa kasi. Isa or dalawa? Dalawa. Kasi if we combine this, if we combine this, may complement pa sila sa taas. So, isa pa ulit. Tama ba? Or sobra na? Ay, sobra na. Try natin. Ayun, mali. Wait lang. Okay. Work our way backwards na lang. Saan yung mali? Ito. Kinumbine natin tong dalawang midterms. They're commutative, so I can combine them without minding the order. So, dapat yan. Okay. Next. Ayan. Okay. So it's the same thing as our given expression over here. So we're done with number 2. And we've confirmed it with this truth table from Logisim. Okay. Let's save our file and answer number 3 naman. Ay, number 4 I mean. So, K-mapping naman to. So, in number 4, it's different from the first 2 questions because we were asked to implement this given function. And so, I've created a spreadsheet based on the K-mapping video lectures 8 to 11. So, these are the gray code for WX and YZ groups, respectively. So in here, we will find trends or groups based on the K-mapping rules. So we can see that 1 and 3 is in our given function, as well as 4 and 6, as well as this whole row, 9, 8, 9, 11, 10, nandito siya. So, color them. Just highlighting them first. And then 13 and 15. So in here, we can spot 4 groups. First group is 1, 3, and 9, and 11. So let's change their color to the group color. Blue color na lang sila. Yan. Blue group na lang sila. And so sa blue group, let's look at the letters, our variables that we can cancel. So we can observe that y changed. From 0, y became 1. So cancel na yan. C, Z, 1. So magsistay si Z. Then CW naman, nag-change din from 0 to 1. Tapos si X naman, 0 pa rin. So complement ni X at saka si Z. Yan. So, complement ni X and C. Yan. So, for our next group naman, next group is this whole row over here. We have 8, 9, 10, 11. Let's just name them the green group. So let's look for terms that we can cancel. We can cancel y. Diba? Kasi 0, 0, tapos naging 1, 1. But can we cancel z? Yes then. Kasi 0, 1, tapos 1, 0. How about w and x? Ayan, nagstay sila. So, w will stay and then the complement of x will stay. So, w will stay ANDed with the complement of x. So, for our next group naman, we have this square over here. Let's just color them yellow. And so we can see that the y changed. So cancel na si y. Si z, 1 siya, so stay siya. Si w, stay din siya. Pero si x, nag-change siya, so wala na siya. So it's w and z. W and z. For our final group, we have 4 and 6 over here. Let's color them orange. Yan. Orange ba yan? Light orange. Yan. Light orange. Let's look for terms to cancel. Y changed. Cancel na si y. Si z, nagstay siya pero complement kasi 0. And the same thing goes for w. And then x will also stay. So w and x ba? Ay, complement of w pala. Complement of w kasi 0 eh. Complement of w and x and z. Complement of z, I mean. And so we have our terms over here, and these terms are ORed together when we implement the circuit. So the question did not specify how we're going to implement them in Logisim. So based on our groupings na lang tayo kukuha ng IC. So I have already prepared a file for this number wherein the AND IC, the OR IC, and the inverter is present. So we will be using this in implementing the circuit for number 4. I will first place the 3 inputs which represent the 3 variables W, X, and Z. And then create their complements using this inverter. Now that I have created their complements, let us go back to our expression and see the first minterm. It is not X ANDed with C. Not X and with C. Okay, so we need an AND IC. Not X. ANDed with C. Okay. This is our first minterm. So for our second minterm, we have W and not X. W and not X. Not X is this signal. For our third minterm, we have W lang and C. W lang, we can get it from here, and C. Okay. So next, our last minterm, not W and X and not Z. Not W. Okay, so we need another AND IC kasi tatlo yung kinoconnect natin. Not W. And then X lang. And then not C. This is our fourth minterm. So finally, we will just be combining these minterms with the OR operation. So finalizing our circuit, we will need an OR IC. So by the commutative property, we can combine any of these four minterms together. Then for the second pair, okay, so we now have these final two outputs, which we will again OR together. Oops, sumobra. Okay, so this is our final output for our whole expression. And to cross-check if this circuit is correct, we will refer to the truth table generator site. Pinrepare ko na yung expression kasi mahaba. Let's double check na lang. The first expression is not X and C. Then the second expression is ORed with W and not X. Third expression is W and Z. And the last minterm is not W and X and not C. Okay. So the only instance where our output signal should be 0 is when all of them are turned off, when X and Z are turned on, or when W and X are turned on. So kung tigda dalawa silang nakabukas and when lahat sila nakapatay. Let's check it using the poke function. Dapat patay. Yan. Pag ito naman. Yan. So let's also double check using the truth table from Logisim. And I think we have the same output. Okay. So that concludes our question number 4. So to recap, I've answered questions number 1 and 2 by first simplifying their expression into a NAND and a NOR expression. And then for the number 4, I first created a K-map and then grouped them into 4 groups wherein Y was cancelled because we only have 3 inputs, and finally implemented the circuit in Logisim using an inverter, 2 AND ICs, and finally an OR IC. And this also concludes my Lab 2 vlog. Thank you for watching!